Going on now to topic 2 of chapter 5, factoring trinomials. And these are the objectives. And generally there are a couple of rules for background here as we go on to do this. And the first rule is that when we start to factor, we want to have the expression in what we call standard form of the quadratic expression. Now, for some of these, the a term is the coefficient of x squared. And if there's just a 1 there, we don't write the a. And we'll start off with some of the easier ones. And then also, we want to take a moment to look at the quadratic expression. Is there a common factor we can take out of each term? We want to factor that out first, after we have it in standard form. Okay, and basically what we're doing is unfoiling this, as we mentioned earlier. Now, keep in mind, the learn that I'm going over is in your software. You could look at this as well, and they go through it in some detail. But I will be featuring this as we go along as well. And we'll try our first example, which we see here. So, what do we have? Well, first, is this in standard form? X squared minus 10x plus 16. And the answer is yes. Second, is there any common factor that we can take out? And the answer is no. So let's go to the whiteboard. Now, once that is accomplished, we then put, and the way I like to do it is this way, 2 sets of parentheses, usually under it, because I'm going to try to undo the FOIL. Now, as we look in the first position here, what would possibly go there? Well, since x is the coefficient of x squared is 1, the only possible combinations would be an x there and an x there. So, doing our first, x times x is x squared. Then we take a look at the c position. Remember, this is ax squared plus bx plus c. And we'll be using a, b, and c throughout our factoring. Now, in the c position, there's 16. So we think mentally, what are the factors of 16? Well, there's 1 times 16. There's 2 times 8. There's 4 times 4. Now, all of these, if we multiply them together, give us 16. But then we have to, and we're doing this mentally, or you can write it out, which of these combinations add up to our b term, which is 10. And as we look at it, well, this one adds up to 10. So we're going to put an 8 there and a 2 there, or you can put the 8 and the 2. That's okay. Now, we look then at the sign of our b term. It's negative, but the sign of our c term is positive. How do we get this to become positive and yet add up when we do our outers and inners to a negative 10? Well, in order for this to be a positive, both of these signs have to be the same. And our negative value, well, we're going to have negative. And as mentioned in the earlier slide, trial and error. You do this in pencil, because if this didn't work, then you might try something else. Then you FOIL this, and you see that it does check out. All right, going back to our regular screen. And there they are down below. All right, let's go on. Now in your notes, example 2, and we'll go to our whiteboard. So as we look at this one, is it in standard form? Yes. Is there any common factor? And you'll notice now our A term is a -3, and there is a 3 that can be factored out of each term. So let's factor out the -3. And then this is our second line, where this now becomes a positive x squared. This becomes a positive x, and this becomes a -12. And again, you can always distribute to check to see if you get your original, and that looks good. So we keep in mind there's a -3 out there. We then put 2 sets of parentheses, and since our A term now is a 1, the only possible items we could put in our first position is the x. Now, we're going to go mentally through 12. We go 1 times 12, 2 times 6, 3 times 4. And notice now that our C term is negative, while our B term is positive. So here we're going to have unlike signs. One's going to be a positive, and one's going to be a negative, to give you that -12. So we're looking for subtraction, and we're a difference of 1 here. So, and we need a positive 1. So our 4 will be positive. Our 3 is going to be negative. All right. Now we do the FOIL. First, x squared. Outers, -3x. Inners, 4x. The difference is a positive 1. So this is the factorization. Now you could have put the -3 here and the positive 4 here. That's okay. That doesn't change anything. And MATLAB will accept all of those. All right, let's go back to our regular screen, and there we see it. Now notice, here they had the positive 4 there, and vice versa, but it works out either way. Now they're not giving us a lot of easy ones. They've jumped into a rather challenging one. And again, trial and error will go through a lot of what is here. You see it gets to be quite challenging. And we'll go to the whiteboard. Now, one of the reasons you take this, again, putting it in standard form, putting your 2 sets of parentheses underneath it. Now, you'll notice our A term is not a 1. So this is where the trial and error comes in. Is this going to be a 6x and an x? Now you'll notice our C term is 7. So if we put the 7 there, this is going to be 6 times 7 is 42. So that's not going to do it. So if you put the 7 there, and the 1 there, this is going to be 6 and 7 is 13. So that's not going to do it. So again, you're brainstorming and you're trying to figure out what goes where. Now, one thing we do know is that there's going to be an x there and an x there. So what next? Well, 6. What are the factors of 6? It could be a 3 and a 2. Again, you're brainstorming. Now, 7 is prime. So 7's going to go there. Let's try it there. Or then later, if it doesn't work there, we could try it there and put the 1 there. But I see it. Notice when you do your outers, you're getting a 21. When you do your inners, you get a 2. 21 and 2 add up to 23. So there it is. But again, you're doing trial and error. And then you foil this, and then it checks out. So that's why we said earlier the foil is so important. All right, let's go back to our regular screen. And we'll go down to see what they ended up with. But again, they go through it in great detail, trying different things. And there it is right there. Now, let me also mention, I'm hoping that up over here in the upper corner of our screen, there'll be a circle with a letter I in it. By clicking on that, I'm going to put some what we call cards, which are links to other videos I made if you need more background on factoring. And in these, I feature what are called the box method, which I recall in the past, one student said, wow, if I had seen that, that would have made it so much easier. All right, let's go on. Now, in this example, and they're calling this number 3, so the previous one you might think of as 2A or background, and we'll go to the whiteboard. And again, trial and error. Now, is it in standard form? Yes. Is there any factor we could take out of each term? No. Now, in our A spot here, we have a 5. Now, 5 is prime. So this has to be 5x and x. That's the only possibility. Now, you could have put the x there and the 5x there. It doesn't make any difference. I tend to do it this way. Now, our 10 here is the key to all of this. And notice that our C term is negative, our B term is positive. So these are going to be unlike signs. In fact, we won't put them in yet. We'll see how it works out. Now, 10. 1 times 10, 2 times 5, and you could go 10 times 1 and 5 times 2. But let's work with the 2 times 5, because the 10 in there, if we had a 10 there, that would be 50. If we had a 10 there, that would be, too little. It's not 23. And in fact, I see it already. And again, that's part of my experience, and hopefully you'll develop that. If I put the 5 there and the 2 there, my outers now are 25. My inners, 2. And the difference is 23. So I've got it. So this is going to be a plus for plus 25. And this will be a negative 2. When you add it together, you end up with a positive 23x. Now, I'm perhaps making it look simple, and when I foiled it, I checked it. Again, practice and thinking about it and going through your various options. And then some of you might want to do that box method there. Okay, and then we just move this down, and there it is. And again, they're showing you all the possible guess and check things here. Now, for example 4, as you do it, just write this down. And notice there is a 2 that can be factored out of each one. And then we end up with this. And then you have x squared plus 3x plus 5. Put that in parentheses. Keep in mind you have the 2 there. And this has to be a 5 and a 1. There's no other possibilities. But when you would do any kind of FOIL, would you ever get this? And the answer is no. There's no at this stage of the game, way to factor this. So we say it is not factorable beyond this example right here. Now, I know that when you do your software and put the items in, there will be a little box saying it's not factorable. And I've seen many students, give up and just check that. But maybe out of 10 examples, you might get one that's not factorable. And on a test, chances are they're all going to be factorable. But there's always that possibility. But again, some of these are challenging, and through practice and review and study, hopefully you'll develop mastery. This will be an important skill that we bring to our next lesson. All right, this will be example 4 and trial and error. Now, here we have a 4 for our A position. Our B position is just a -1, and our C is a -5. So thinking about it, you might say, what would I try first? Well, because my B is so low, I'm going to try a 4x and an x. Now remember, if that didn't work, you'd go a 2x and a 2x. But 5 is prime. So 5 is either going to go here or there. But we're looking for a difference of 1. If we put it here, we're going to get a 20. So that's not going to work. I'm going to put the 1 there. And I'm going to put the 5 there. Now notice 5, our C term is negative. So one of these signs has to be negative. And our difference is a -1. So think about it. What signs will you put? Well, I need a negative for the middle term. So this is a -5x. Now my others will be a positive 4x. And the difference is a -1. So there's the solution. Now, again, depending on what you've done, and you're writing this in pencil because you're guessing and checking, and then foiling it to prove that you are correct. And here they show the various possibilities, and they end up with what we have. This will be background information now, and I'd like you to write all this down. This is the AC method. Now, where does this method come from? Well, the A is the coefficient of x squared. The B is the coefficient of x. And C is this constant. So let's go through the process. Now, it's all written up here, but I'll do it verbally for you. And we'll use the whiteboard. So what is your A term? Well, A is going to equal 2. Our B term is going to be 9. And our C term is going to be 10. Now, in the AC method, the first thing you do is you multiply the A term by the C term. And that'll give you AC. And that'll be 2 times 10 is 20. Okay. Now, if your AC, the product of that is 20, this came about by multiplying 2 factors together. So we then mentally think of what are the factors of 20? Well, there's 1 times 20. There's 2 times 10. And there's 4 times 5. Now, if we added these factors together, here this would be a 3. This would be a 12. And this would be a 9. Now, when you do multiply these factors together, which combination of the factors give you your B term? And it looks like this one right here. They didn't give us too hard a one for this to illustrate this. So that's 9. So now we're going to rewrite this. 2x squared plus 9x plus 10. We're now going to take our factors here and write an equivalent equation separating our b factors into 2 parts. And you get that 2x squared plus this one here, 4x, then the 5, plus 5x, and then you bring in your c term, plus 10. Now notice that this 4-termed polynomial is equal to this 3-term trinomial. And now what are we going to do? Well, we're going to factor this by grouping. A skill we had in our last section. So here we can take out a 2x, and we're left with x plus 2. And from this, we can take out a 5, and we get x plus 2. What we had in our last section. So now we get 2x plus 5, this and this, times x plus 2. And this is the AC method of factoring. Now, you could have brainstormed this, thinking, guess and check, but we want you to be familiar with the AC method. One of your quiz questions will be in one of these examples, what does AC equal? Well, you're going to multiply your A term in the example I give you by the C term, and you're going to get 20. Okay, now let's check this out and see what they have. And I'm going to erase mine so you can see it a little better. We're just going to go through describing all of the steps that we've done. And again, if you want to read it, for some of you that might be useful too. This is available on page 10 of the Learn. And this is what we've gotten. Now, before I close this, again, keep in mind that many of these have videos by the authors and their staff that go through this. So you can go back and check these videos out. But what I'm going to do is work this one out for you. And up here in your notes, for example 6, you're going to put x squared minus 2x minus 15 that they want you to work using the AC method. Okay, now A is 1, so 1 times 15 is going to be a negative 15. Now we're looking for factors of this that are going to add up to a negative 2. And again, you can write them all out, but I see it's going to be 5 times 3. And I need a negative 5 and a 3. This will add up to a negative 2. So now we're going to rewrite this x squared using our factors here. Let's say a positive 3x, and then we're going to have a negative 5x, and then we have a negative 15. Now notice this and this are the same. We just haven't combined our like terms. So we're going to factor this now by grouping. And here we can take out an x, and we're left with x plus 3 And here we want to get an x plus 3. And you might recall from our toolkit, if we take out a negative 5, that will do it. And we reverse the signs. So our factorization is x minus 5, and then an x plus 3. We've used the AC method. Now you could have brainstormed and do the guess and check as well. And going back and then clearing this up, we see this is what you get. And there is the answer. Okay, this is running a little long, but we're doing a lot of different kinds of factoring here. And for example, 7, another AC method, and we'll jump to the whiteboard. Now, as you look at this, you see, can we take out any common factor? There was an x here too. And the answer is yes. You can take out a 3x from each of these. So now this becomes 6x squared minus, this one is 13x. And this is going to be plus 6. But they want us to use the AC method here. So A is 6 and C is 6, so AC equals 36. Now our middle term is a negative 13. So we're looking at factors of 36 that add up to 13. So again, I can see it. It's going to be 4 times 9 is 36. And that adds up to 13. So now I have to rewrite this. And I'll keep in mind there's going to be a 3x eventually. But I'm just going to deal with this part here. So this is going to be 6x squared plus 3x, oh, wrong one, 4x and then plus 9x, and I see I've got the wrong signs. I'll change them in a minute, plus 6. And my signs should be negative here. And that's why you have to check your work. All right, here we go. That's better. So now this is equivalent to this, but we're going to use factoring by grouping. And here I can take out a 2x and get 3x minus 2. And here I can take out a negative 3, and I get x, 3x minus 2. All right. So this goes in one parenthesis, 2x minus 3, these two, and then this goes in the other, 3x minus 2. And don't forget our initial 2x, 3x from out here. So there we go. Again, I'm kind of concerned this is running long. I'm trying to go as fast as I can, but yet not too fast. Let's check it out. Clear this up and bring this down. And you see they take quite a while, and they get what we have. Okay. Now, if this parenthesis is over here and vice versa, that would be perfectly good. All right. Now, for the last slide, they give us tips to keep in mind while factoring. So it summarizes it, but we'll call this the end.